10 scientists gathered at the Green Bank Observatory in West Virginia back in 1961, and they sat down to answer humanity's oldest question using a simple equation. Their calculations suggested the Milky Way should contain somewhere between 10,000 and 1 million technological civilizations. 60 years have passed since that meeting, and in that time we've built radio telescopes sensitive enough to detect a cell phone signal from Jupiter. We've confirmed over 5,000 worlds orbiting other suns across the galaxy. Our instruments have listened to the cosmos with a precision those 10 scientists could never have imagined. And we've heard nothing. Not a signal, not a whisper, not a single hint that anyone else exists out there. The physicist Enrico Fermi asked the question that now carries his name when he said, "Where is everybody?" And that contradiction between the high probability of extraterrestrial civilizations and the complete absence of evidence for them is what we call the Fermi paradox. Most people imagine two possibilities when they think about this question. Either aliens exist out there somewhere, or the universe sits empty except for us. Simple, binary, comfortable. But when you follow the evidence where it leads, you discover something that changes everything you thought you understood. Both answers turn out to be equally terrifying, and the silence itself carries information. Every year, we fail to receive a signal, adds another data point, suggesting something deeply uncomfortable about the fate of civilizations like ours. The cosmos is all that is or was or ever will be, and our feeblest contemplations of it stir us in ways we struggle to describe. There's a tingling in the spine, a catch in the voice, a faint sensation like a distant memory of falling from a height. We know we are approaching the greatest of mysteries when we look upward. The surface of the Earth is the shore of the cosmic ocean, and on this shore we've learned most of what we know about existence. Recently, we've waded a little way out, maybe ankle deep, and the water seems inviting to us. Some part of our being knows this is where we came from, and we long to return because the cosmos is also within us. We're made of star stuff, which means we are a way for the cosmos to know itself. The nitrogen in our DNA, the calcium in our teeth, the iron in our blood, the carbon in our apple pies, all of it was forged in the interiors of collapsing stars billions of years ago. Your iron atoms have a family tree that can be traced to a specific supernova that exploded before our sun was born. We are not separate from the universe in any meaningful sense. We are the universe contemplating itself, star stuff pondering the stars. And if we arose from this cosmic chemistry, the question becomes, why not others? Imagine compressing the entire history of the cosmos into a single year, a cosmic calendar where the Big Bang occurs at the stroke of midnight on January 1st, and the present moment falls at midnight on December 31st. Each month on this scale represents a little over 1 billion years, and each day covers nearly 40 million years of cosmic time. The Milky Way galaxy doesn't form until sometime in March on this calendar. Our sun and solar system don't appear until early September. Life on Earth begins around September 21st, which means everything that followed took only the last quarter of the cosmic year to unfold. But we humans show up in the last few seconds of December 31st. Our entire recorded history, every pharaoh and philosopher, every war and work of art, occupies the final second of the cosmic year. We are like butterflies who flutter for a day and think it is forever. All that time stretches behind us, all those billions of years before humans existed, and in that vast span, other intelligences might have arisen. They might be arising still, on worlds we cannot yet see, around stars whose light is only now reaching Earth. Our small group at Green Bank called ourselves the Order of the Dolphin, a whimsical nod to ongoing research into dolphin communication and our shared conviction that intelligence might take many forms throughout the cosmos. Frank Drake called us together to discuss something unprecedented, a systematic scientific search for extraterrestrial intelligence. And to focus our thinking, he devised something remarkable that was not an answer but a question, the right question framed in the language of mathematics. The Drake equation. Think of it as cosmic actuarial science, because insurance companies calculate your likelihood of survival based on dozens of factors like age, health, occupation, and habits. We were calculating the same thing for civilizations across the galaxy. And like any actuary will tell you, the numbers don't lie. They just deliver verdicts we may not want to hear. The equation looks deceptively simple at first glance. N equals R star multiplied by F sub P multiplied by N sub E, and so on, through 7 factors, each representing something we would need to know to estimate the number of communicating civilizations in our galaxy. R star is the rate of star formation in the Milky Way, and we know this fairly well at perhaps 10 new stars per year. F sub P is the fraction of those stars with planetary systems. And in 1961, this was pure speculation. But today, thanks to missions like Kepler and the James Webb Space Telescope, we know it approaches one because almost every star has planets. N sub E is the number of planets per system that could potentially support life. F sub L is the fraction of those planets where life actually arises. F sub I is the fraction where intelligence evolves. F sub C is the fraction that developed technology capable of communication. And finally comes L, the average lifetime of such civilizations. Here's what keeps me awake at night. When you work through the first several factors with reasonable estimates, estimates that have become more optimistic as our knowledge has grown, you arrive at a startling conclusion. Life should be common throughout the galaxy. Intelligence should arise on countless worlds. Technological civilizations should develop across the Milky Way. And yet the cosmos remains silent. We have been searching since Project Ozma in 1960, when Frank Drake pointed a radio telescope at Tau Ceti and Epsilon Eridani, hoping to catch a whisper from the stars, and he heard nothing then. The SETI Institute has continued the search for decades since that first attempt. The Breakthrough Listen project, funded with $100 million, now scans the skies with unprecedented sensitivity. We've found pulsars and quasars and the cosmic microwave background radiation, which is the echo of the Big Bang itself. But no signal has arrived, no message, no hello from the darkness. Extraordinary claims require extraordinary evidence, and that's a principle I hold dear. I remain skeptical of UFO reports and claims of alien visitation, not because I don't want them to be true, but because the evidence doesn't support them. Anecdotes and blurry photographs fall short of what we need. If extraterrestrial beings had visited Earth, we would expect evidence that could withstand scientific scrutiny, and we don't have that. But the absence of visitors is not the same as the absence of life. The distances between stars are so vast, and the energies required for interstellar travel so immense that we cannot conclude from our apparent solitude that we are truly alone. Our galaxy contains roughly 400 billion stars, and if only 1% of them have planets, which we now know is far lower than the actual number, and if only 1% of those planets are suitable for life, and if life arises on only 1% of those, and intelligent life on only 1% of those, and technological civilization on only 1% of those, we're still talking about 400 civilizations in our galaxy alone, and there are hundreds of billions of galaxies scattered across the observable universe. If we are alone in the universe, it seems like an awful waste of space. Thomas Carlyle said something similar centuries ago when he looked up at the stars and called it a sad spectacle, saying, "If they be inhabited, what a scope for misery and folly, and if they be not inhabited, what a waste of space." But here's what most people miss entirely when they think about this question. In the Drake equation, one factor dominates all others in determining whether the galaxy teems with civilizations or lies barren of intelligent company. L, the lifetime of a technological civilization. Some call it the great filter, this idea that somewhere between dead chemistry and galaxy-spanning civilization there's a barrier that almost no species passes through. The question that haunts me is whether that filter lies behind us in our evolutionary past or ahead of us in our future. Think about what that means and really consider it for a moment. We have possessed the technology to destroy ourselves completely. Every city, every library, every memory of human achievement for less than a century. In cosmic terms, we developed nuclear weapons yesterday. We learned to broadcast radio signals into space the day before that. Our entire technological civilization, from the perspective of the 15 billion year history of the cosmos, occupies an infinitesimal sliver of time. And in that eye blink of existence, we have already come terrifyingly close to ending it all. Not once, not twice, but repeatedly. There were moments during the Cuban Missile Crisis when the fate of human civilization rested on the judgment of a single submarine commander named Vasily Arkhipov, who chose not to launch a nuclear torpedo. He chose against protocol and against the urging of his fellow officers to wait, and in doing so, he chose life for all of us. We didn't know at the time how lucky we were. When I contemplate the Drake equation, I find myself returning again and again to that final factor, L, the lifetime of a technological civilization. The answer to our cosmic loneliness may lie not in the rarity of life, nor the improbability of intelligence, but in a simple and terrible truth. Civilizations like ours may not last very long. It might be a familiar progression, transpiring on many worlds throughout the cosmos. A planet newly formed placidly revolves around its star, while life slowly forms on its surface. A kaleidoscopic procession of creatures evolves over billions of years. Intelligence emerges. and up to a point it confers enormous survival value on those who possess it. And then technology is invented. It dawns on them that there are such things as laws of nature, that these laws can be revealed by experiment, and that knowledge of these laws can be made both to save and to take lives on unprecedented scales. Science grants immense powers, they recognize, and in a flash they create world-altering contrivances. Some planetary civilizations see their way through and place limits on what may and what must not be done, safely passing through the time of perils. Others, not so lucky or so prudent, perish. This is what I call technological adolescence. The human prefrontal cortex, the part of the brain that governs impulse control and weighs long-term consequences against immediate gratification, doesn't fully develop until around age 25. Civilizations may have their own version of this developmental stage, where they can split the atom before they've developed the collective wisdom to ensure they won't use it to destroy themselves. Our technology has outpaced our maturity in ways we barely recognize. We are adolescents playing with matches in a room full of gasoline, not quite understanding that the game could end at any moment. The same rocket to nuclear and computer technology that sends our ships past the farthest known planet can also destroy our global civilization. Exactly the same technology can be used for good and for evil. It is as if there were a God who said to us that he set before us two ways, and we can use our technology to destroy ourselves or to carry ourselves to the planets and the stars, and that it's up to us to choose. My research on nuclear winter in the 1980s used the same atmospheric models that now inform our understanding of climate change, and it showed that even a limited nuclear exchange could darken the skies and collapse agriculture worldwide. The mathematics of extinction is the same, whether the cause is asteroid impact or human folly. We are the first species in the history of Earth capable of determining our own fate, and that is both our greatest achievement and our greatest danger. Consider what it would mean if we received a message from another civilization. Any civilization capable of sending us a message would, by definition, be more advanced than we are. They would have survived their technological adolescence, passed through the great filter, if that's what it is, and found a way to live with the terrible powers that science confers. The receipt of a single message from space would carry profound hope. It would show that living through technological adolescence is possible, that self-destruction is not inevitable, that a civilization can mature beyond its most dangerous impulses. Such a message, quite apart from its contents, would be the most transformative event in human history. It would mean that someone made it through. This is why SETI matters so much, because we're not merely searching for company in the darkness. We're searching for evidence that survival is possible, that the gauntlet we're running can be navigated, that there's a future beyond the perils we've created for ourselves. This is the theme I explored in my novel Contact, the idea that a message from the stars would answer not just whether we're alone, but whether we have a future at all. Imagine what such a civilization might know. They would have survived not just nuclear weapons, but perhaps climate catastrophe, biological warfare, artificial intelligence run amok, and dangers we cannot yet conceive. They would have learned to balance the power of their technology with the wisdom to use it responsibly. They would have solved problems we haven't even learned to ask yet. And here's something worth considering. If civilizations tend to destroy themselves quickly after developing technology, then the galaxy should be relatively quiet, which is what we observe. But if even a small fraction survive and endure for millions of years, they would have had time to explore and expand and make their presence known. The absence of such evidence is itself a kind of message, and the silence isn't empty, but rather a verdict. We have been listening for decades with our radio telescopes, searching for any sign of intelligence, any signal that might break through the static. The wow signal of 1,977 remains unexplained, 72 seconds of data that matched what we'd expect from an artificial source, but it is never repeated. A few tantalizing anomalies have appeared over the years, but the apparent silence has been deafening. Andrew and I led a team in 1977 to create something unprecedented. We launched two spacecraft called Voyager, and on them we placed golden records, phonograph records, that were delicate and gleaming and contained sounds and images and music from Earth. The records held greetings in 55 languages, beginning with Akkadian, which was spoken in Sumer 6,000 years ago. They included the sound of a mother's kiss and whale songs and music by Beethoven and Chuck Berry. A message in a bottle cast into the cosmic ocean. 3 years earlier, we had sent a simpler message from the Arecibo radio telescope in Puerto Rico, a 3-minute broadcast aimed toward a star cluster 25,000 light years away. It will arrive in the year 27,000, and these are the kinds of timescales we must think in when we consider contact with other minds. The Voyager spacecraft will be encountered, and the record played only if there are advanced, spacefaring civilizations in interstellar space. But the launching of this bottle into the cosmic ocean says something hopeful about life on this planet, regardless of whether anyone finds it. Both voyagers have now left the solar system and entered interstellar space, the void between the stars. 40,000 years will pass before they make a close approach to another planetary system. And in all that emptiness, in all that vast dark between the stars, there is no guarantee anyone will ever find them. And yet we sent them anyway, because hope is as fundamental to the human spirit as curiosity, because we refuse to believe we are alone. We make our world significant by the courage of our questions and by the depth of our answers, and asking whether we are alone is perhaps the most courageous question humanity has ever posed. Any answer changes everything we understand about ourselves. Some people find it depressing to contemplate our cosmic insignificance, but I find it elevating. Our universe permits the evolution of molecular machines as intricate and subtle as we are. Atoms, given 15 billion years of cosmic evolution, can come to contemplate their own origins. We, these collections of water and calcium and organic molecules, can send our thoughts and our music into the void, hoping someone might hear. We inhabit a universe where atoms are made in the centers of stars, and where each second 1,000 suns are born. Life is sparked by sunlight and lightning in the airs and waters of youthful planets. The raw material for biological evolution is sometimes made by the explosion of a star halfway across the Milky Way. A thing as beautiful as a galaxy forms 100 billion times across the observable universe, creating a cosmos of quasars and quarks, snowflakes and fireflies, where there may be black holes and other universes, and extraterrestrial civilizations whose radio messages are at this moment reaching the Earth. How pallid by comparison are the pretensions of superstition and pseudoscience. How important it is for us to pursue and understand science that characteristically human endeavor. Look again at that dot, because that's here, that's home, that's us. On it, everyone you love, everyone you know, everyone you ever heard of, every human being who ever was, lived out their lives. The aggregate of our joy and suffering, thousands of confident religions and ideologies and economic doctrines, every hunter and forager, every hero and coward, every creator and destroyer of civilization, every king and peasant, every young couple in love, every mother and father, every hopeful child, every inventor and explorer, every teacher of morals, every corrupt politician, every superstar, every saint and sinner in the history of our species lived there on a mote of dust suspended in a sunbeam. Our posturings, our imagined self-importance, the delusion that we have some privileged position in the universe are challenged by this point of pale light. Our planet is a lonely speck in the great enveloping cosmic dark. In our obscurity, in all this vastness, there is no hint that help will come from elsewhere to save us from ourselves. Think of the endless cruelties visited by the inhabitants of one corner of this pixel on the scarcely distinguishable inhabitants of some other corner. Think of how frequent their misunderstandings, how eager they are to kill one another, how fervent their hatreds. And here is the uncomfortable truth. The answer to whether we are alone may be yes, but not because life is rare, not because intelligence is improbable, not because the cosmos is inhospitable to minds like ours. We may be alone because civilizations at our level of development tend to destroy themselves. The window of time between developing radio telescopes and developing the means of total annihilation is vanishingly small. Technological adolescence is a filter that few pass through. L, that final factor in the Drake equation, turns out to be terribly and heartbreakingly short. If this is true, if the silence of the cosmos reflects not the absence of life, but the brevity of civilizations, then we are living through the most critical moment in human history. The choices we make now, in this generation, may determine whether we join the cosmic community or become another data point in the great filter's long record of extinction. Every one of us is precious in the cosmic perspective. If a human disagrees with you, let him live, because in 100 billion galaxies you will not find another like him. There is something else that offers a different kind of hope. We are young. Our species is young and curious and brave and shows much promise. In the last few millennia, we have made the most astonishing and unexpected discoveries about the cosmos and our place within it, explorations that are exhilarating to consider. They remind us that humans have evolved to wonder, that understanding is a joy, that knowledge is prerequisite to survival. We have accumulated dangerous evolutionary baggage, propensities for aggression and ritual, submission to leaders, hostility to outsiders, all of which puts our survival in some doubt. But we have also acquired compassion for others, love for our children, a desire to learn from history and experience, and a great, soaring, passionate intelligence These are the clear tools for our continued survival and prosperity. Which aspects of our nature will prevail remains uncertain, but it is not foreordained. We have a choice. Exploration is in our nature. We began as wanderers, and we are wanderers still. We have lingered long enough on the shores of the cosmic ocean, and we are ready at last to set sail for the stars. But first, we must learn to live with ourselves. We must pass through technological adolescence and recognize that the same science that can destroy us can also save us, can carry us to other worlds, can give us the stars. The choice is with us still. The civilization now in jeopardy is all humanity. We are the local embodiment of a cosmos grown to self-awareness, and we have begun to contemplate our origins. Star stuff pondering the stars, organized assemblages of 10 billion atoms, considering the evolution of atoms, tracing the long journey by which consciousness arose here on Earth and perhaps elsewhere. Our loyalties are to the species and the planet. We speak for Earth. Our obligation to survive is owed not just to ourselves, but also to that cosmos, ancient and vast, from which we spring. Are we alone? Perhaps we are, perhaps we are not. But either answer carries the same imperative. We must cherish this pale blue dot, the only home we've ever known. We must pass through this dangerous time. We must find a way to live with the powers that science has given us. Because if we don't, the question of whether we're alone in the universe will be answered definitively. And the answer will be yes,